So, welcome again with this picture of Tower of Babel. So, I think the human mind itself created this story of Tower of Babel, because however different the various structures and various complexity, the geography and history of brain may appear, it is still smart to find out its own way of communicating through chemicals, through electricity, and with this all single neuron activity of electrochemical transmission of signal, the brain also, so it evolved cell assemblies. Whatever, wherever they are situated, they can always fire together, and then this huge network. So, let us see what more it can tell us. If you see this picture and just read this word, if you can read some of them: love, freedom, passion, creative, strategic, control, left analytical brain, right intuitive brain, that is what it is understood. But this whole plethora of activity is created just by these networks and assemblies. This is very interesting, because it is just an example how the networks of the brain, this is actually has evolved. The graph theory has become very popular in neurosciences research these days, and graph theory says that there are nodes. These nodes are interconnected to various roots and various. So, somebody, I think this is one of the site, I do not remember, I think it is called Brain Scan or something. They have tried to really see. So, you see these various colored things, all these red areas are the basic functions of brain, mind. These greenish areas are the brain structures, and these are illnesses, and this is how they have created. And this oranges are this. So, these are investigative, these are areas, these are illnesses, and these are functions. Social cognition is connected to cognition. Executive function is again connected to working memory. Episodic memory is again connected to cognition. Prefrontal cortex is connected to working memory, to cognition. Alzheimer's disease, dementia is again connected to cognition. Cognition is connected to Alzheimer's disease. Social cognition is connected to theory of mind. Theory of mind is the way I told you about mirror neurons. Theory of mind is about thinking, about what the other person is thinking. That is how your brain perceives. You cannot think what, and this is very strange now that this word has come up. We think that we can think objectively, but if you look at it, our thoughts most of time they are derived from what others are thinking. So, in English there is a saying which says, small minds think about people, medium minds think about incidents, great mind thinks about ideas. But this is a myth. It's a very difficult thing to say, because all our thinking, see, there is no human endeavor in this world which does not concern humans. Even if you are trying to make a robot, it is about humans. You are trying to make weapons, it is about women. You are trying to make some small utility thing, it is about humans. So, our brain has developed this theory of mind of what others are thinking. So, our brain, what we think we can think or we think, is embedded in what the other is thinking. So, lot of our self has been formed by others. So, we do not live in isolation. So, if you say this is me, my me does not have only me. It will have so many inputs from my friends, from my parents, from religion, from everything which has gone in. So, I am derived from you. So, whatever philosophy and other people may argue, our mind does not work in isolation. So, you see Parkinson's disease, depression, they again go connected with these type of stuff. So, this is a graph theory network which is very popular, and a lot of there is a guy called Olaf Spons. He has brought out a theory of what we call a connectome, and it looks at network theory of brain. So, you can read about it, there is a lot available on the net, there is a e-books also available, or maybe towards the end if you find time we can discuss this. So, there is no, see this is again a representation of the type of network. This is a motor proprioception, that is the things going from the joint, visual, auditory, olfaction, and this is the type of network which connects with visual thing. There is no more important quest in whole of science probably than the attempt to understand those events in evolution by which brain worked out a special trick that enabled them to add to the scheme of things. So, in the general scheme of things, the brain has evolved in a way where it has taken all these things and trying to integrate into a mental experience. So, the big question still, or maybe I will ask you the big question at the end of it. You know this and you know this, the whole thing we have talked about it, right. This is again the neuron. These are the different type of 50 type of neurons available. These are some of them: visual, auditory, somatosensory. Why have they differentiated like this? All students should have an idea, because see all the same. Somatosensory is touch, pain from joints, auditory is sound, visual is light, vision. Why are they different? Because from here everything may be a electrical energy, here everything may be a chemical energy, but when it comes from the environment, the energy transfer is different. These are sound waves, pressure waves through which you hear. These are mechanical or thermal depending on heat and all that, and this is electromagnetic. So, the brain is smart enough to evolve in a way that this will catch the photon, this will move in response to the pressure mechanical wave, this will respond, and that is how you get all this thing. Ultimately, everything converts to electrical activity getting transmitted through chemical activity. So, this energy converts to electrical energy converts to chemical energy, maybe chemical energy again to electrical energy, and once your cortex decide. So, let me give you an example. If somebody maybe shows you a fist, so it is actually the electromagnetic thing which is going in, the movement, and it goes after a lot of processing in 200 milliseconds to your, or within 100 milliseconds as a reflex action. So, reflex action does not go to the conscious level, we will talk about it when it comes to it, and you decide to punch him back like this. So, it is possible that this energy which has gone in has undergone chemical electrical changes, and finally, electrical energy is again converted to what? To mechanical energy in pushing this. This energy cycle is complete. Or if it touches, the heat goes in, changes to electrical activity, goes to chemical, again to electrical, and your hand pushes, again that maybe that cycle is complete, if broadly you look at energy transfer. But what if you don't? If you don't move, you suddenly think, then how does this electrical activity change to thought? So, when you feel fearful, then how does this electrical activity change to emotion? What is that transfer? That is the biggest standing question of brain right now, and that is what David Chalmers, a philosopher, calls a heart problem of consciousness. We will talk about it when we talk of consciousness. So, this we know, they are connected to synapse, excitatory inhibitory connections, This is a basic synapse again. So, the simplified, very idealized type of neurons are used in artificial neural networks. Whole activity is to train the neural networks like brain. So, the whole AI thing wants to stand that we want to make a machine where neural networks will automatically become more intelligent, feel emotions, decide, but that probably it may come on its own, but right now because we do not have a full understanding of the brain, as I told you the biggest question, the hard problem. ANNs are artificial, but they have provided, and that is where the value lies. So, what they started in creating a brain like thing, their work has given us some understanding of how the brain functions, possibly. Again, I am not saying that all that is real. The success of technology does not mean always that the basics are clear. It may be a lot of variables which may work. So, this is a typical idealized thing. These red ones are inhibitory, and these are excitatory, and this whole summation, like we looked at the Pitts neuron or Hopfield thing. The 6 working assumptions with neural networks. They use a integrate and fire action. Integrate what? Integrate EPSP, IPSP, right? And the weightage, as McCulloch says. So, it is like this. This is a neuron, this is a reception, integration, right? This is a intrinsic firing going on, there is a encoding and there is output. So, integrate and fire, integrate whatever is coming into it, integrate that, do all the summation and fire. Connections are either excitatory or inhibitory, we know this, EP or IP. Idealized neurons, again as I said, neurons typically form two-way pathways, providing the basis for re-entrant, which is called a feedback thing. It will not be always just the whole thing comes in, it fires, it goes output over. It will keep giving feedback to the higher center, to the lower center, because that determines whether it is going to respond to it or not. Like there is an explicit feedback connection. These are objects, right? These are stimulus. These are stimulus which formulates here, it's form here, it goes here, and you finally see this. This is a feed forward thing. Feed forward means if you keep feeding in stimulus, all stimulus will keep getting integrated till they give you a representation of the external world. And the feedback again, this representation of the external world in the brain again goes back to the point where you are seeing it. You are seeing something, are you really seeing it in first place? Whatever is going in is a light from your eye or a sound from your ear. It gets converted to the same electrochemical signal. Maybe there are, suppose there is a, so do not get confused, this is the real state of neurosciences where we do not understand anything. Now, suppose there is a structure like this, and there is something called suppose X. Now, this X has to be transmitted in your brain. Things go from here, from here, from here, from here, but this is all electrochemical activity, and from each point this separate data set is going, maybe thousands of neurons. Again within the brain, these things are integrated to form this X thing, over which intrinsic maps will also act. So, what you are seeing is just a representation of this external X object formulated through the various integration. Now, the big question is, will the neurons fire in the pattern of X? Only these many neurons along these lines? No, it is very unlikely. The unlikely thing is, do neurons fire in this pattern and all the other neurons are inhibited by the side? What is your guess? Take your guess. It is very unlikely, because there will be lot of things which are going on from side also. So, the chances a whole cluster of neurons are firing, from which this X has to be deducted and presented to whatever higher cortex. Internal imagery and memory will also contribute to this. So, there is a external object, its image. I told you left field and right field. There is an internal image which will compare with whether X is already existing. This will give a composite image to the higher cortex. Now, if they are same, it is wonderful, but if they are not, then the brain will always prefer the image which is relating directly to the external world for survival. Suppose there is a lion's face which comes to your head, lot of firing goes on feature extraction, your brain reconstructs a hazy picture of a lion, but your internal imagery is seeing your girlfriend's face on the jet. What is brain going to prefer? The brain will prefer the external imagery, because that is a threat, right? And this will be suppressed. Take it vice versa, that it is your spouse's face and she appears to you, she or he appears to you like a lion who is going to eat. Even then it will prefer, the brain will prefer. But this type of stuff goes wrong. So, the internal image is suppressed by the higher center. But this goes wrong in something where hallucinations are happening. Hallucination is feeling a perception without the real stimulus outside. So, the whole thing will go like this, because the brain starts believing the internal imagery, and that is when you call it losing touch with the reality. We are in touch with reality because we are in touch with the external stimulus. In hallucination, we lose touch with the reality, because the internal imagery superimposes or goes beyond the required intensity. So, every second, every instance, lot of inputs are going. So, what happens? The brain keeps forming maps of whatever is going on. These maps are like pain maps, like touch maps. You remember that parietal lobe thing where face is represented. All those are maps actually, maps coming from the face, maps coming from the big toe, maps coming from this, visual maps, auditory maps, tonotopic maps. So, these are like layer after layer after layer after layer. Basic layer of neural networks, then there is a layer which of thought, of layer emotion, experiential mapping. It just grows in complexity, and this is all what Dr. Hebb said, which so they work in integrate fire, excitatory, inhibitory, neural networks, neurons, and Hebbian cell assembly, presynaptic, postsynaptic firing together. From transient presentation, something comes, it fires, it goes here. Now, if this refiring does not appear, then it will be a transient thing which will come and go, you will not remember it. So, presynaptic, postsynaptic, when they fire repeatedly together again and again, it is transferred to stable lasting connection. So, that repetitive re-entrant firing is very important. Suppose something stimulates your few cells, and the postsynaptic also fires, you forget it, you do not bother. But if it happens repeatedly, that is how phobias are formed, that is how fear comes in. Now, sometimes the repetitiveness is also not required. With the natural calamities like earthquake, and if you are exposed suddenly in a short time with a huge amount of emotional stress, it can alter the synapses in one go. It will be so strong, but that rarely happens, that the disturbance will immediately be preserved. That will only happen when there is a huge threat to survival, like it happens in natural calamities. Lot of people even after that, probably that is the basis of an illness called post traumatic stress disorder. One earthquake And there will be a lot of people after months also in their dreams, they will be seeing the same thing when they are. I have not talked about sleep yet. What we are talking about is the immediate one-off firing vis-a-vis repeated firing, which establishes the connection between presynaptic and that is a short-term memory. How this short-term memory actually goes into long-term connection is a different state of mind. We will talk about it. So, it is like this, see, maps flow into each other. The nervous system often uses layers of neurons in giant arrays. This is just one example. These are the areas of the visual thing, V1, V2, medial temporal, V4, inferior temporal gyrus. If you remember, what, where. So, this is the type of lateral geniculate nucleus is where all the visual input come, where left, right things are presented. It goes into V1 where there are blobs. Blobs are like these small areas. There is another. Between these are interblobs. So, blobs may get activated, the areas surrounding it may get inhibited. Now, you look at it, what I was talking about X, a lot of stuff may go in, but when it goes to cortex, it is still will form like this. These areas will activate, which will form the pattern. Okay. Then you go to V2, there is a certain area which judges movement, color, pages, goes to temporal, which says what, parietal says where, space and time. This is space, this is time, temporal comes from it. And this is the type, so this is just an arrow diagram. Now look at it, this is the type of stuff which goes. V1, the huge data decreases, again this comes to this. Two-way connection. It is very rare to find brain traffic that is not two-way. If you can make one-way pathway, you can still see, but what are you going to do when you see it? You have seen it, there is nothing to give a feedback to after I have seen it. So, this higher cortex which is seeing it will always give a feedback to the basic visual cortex from where stimulus is being coming, or maybe to eye, we really do not know. So, if you remember there is a parietal lobe, there is a frontal lobe, there is a differentiation. So, sensory and motor system they work together. All cortex can be thought about in terms of sensory and motor hierarchies, with information flowing between the posterior sensor area where all these things have come to frontal. So, there is a polymodal means proprioception, thermal, this, that, okay. And so, the primary sensory area is here, the whole thing comes here. There is a different thing, premotor, rostral, prefrontal means from the front. So, if all senses go, so your brain will sit on all senses, wait for it to decide, it is not going to happen. All senses go because it has to decide whether you are going to move, you are going to do something or you are not going to do something. Now you can connect all this drama of network, maps, everything is going to happen through this spikes and brain rhythm. Now get back to your oscillations, where I told you that over and above this spikes are happening. These spikes ride over this existing patterns to integrate every new information and memory into the already existing one. So, the spike and rhythm, they are two most important things. You have seen this is Necker's cube. This is I told you about ambiguity. Brain does not want ambiguity. So, ambiguous figures are a point in which brain has to take a decision about how to interpret sensory input. So, the debate is whether brain has a will in it, whether brain has a conscious thing in it, whether brain has, that is a philosophical debate is different, but whether there must be a will or intent, because will and intent decide attention. Whether that will is free will or something is a different issue. That we will talk about when we talk of consciousness. So, there is a choice points in the flow of information. Even between these networks, between 1 and 2, there is always a choice point. Now, these choice points are decided by the unconscious firing of the brain, or is there a conscious choice? That is a $1,000,000 question, still unanswered. I may choose to, whether I am seeing this vase or faces, or whether I am choosing this, whether I am seeing it like this, or whether I am seeing it the other way when the red comes out. So, this is what Hebb said. So, now the question is, if you go back, that brain, since it has been formed when it was simple nervous system, it has learnt how does it transmit. It still transmits. How does the other next brain learns how to do it? How does the neighboring brains learn about it? So, like Darwin brought out a concept of natural selection, that all the good things which help you survive are retained in your genes, and that is called survival of the fittest. Edelman brought out this concept of neural Darwinism, that once the brain has responded to certain thing in a certain way and it has helped it survive, it will keep repeating that. And that is, if you remember, you can always attach it to pleasure and pain principle, reward and punishment. There are certain areas of brain which give you, which make you a pleasurable feeling when you are doing it. So, you will do all those things again. If you are having a painful feeling or a negative reinforcement, you will not do it. So, obviously, when you talk of people doing sin and addiction, obviously they get a kick out of it. You may tell them it is a bad or bad, but the brain is giving them a kick. It may have come out of conditioning. Conditioning means environment has worked on this neuron to train them again and again and again and again, and that has passed on. So, this is encoding of any behavior in the brain. There is an interference from various other sources, right. So, this red thing again keep firing in the, so what is left? This is the encoding which is happening. Now, interference has gone, this is left, this will keep reverberating, firing again and again, again and again, and the whole thing will amplify. Finally, it will be storage. This is neural Darwinism. Stages of encoding and neural activation pattern and let dynamic synaptic activities allow permanent connection to be strengthened, and that is going to be passed. This is symbolic processing again. So, the brain represents a large set of propositions, and so brain is actually, if you are, it is handling symbols, or you can call it metaphor about metaphor. Symbolic processing. This is a pen. Somebody would have started calling it a donkey. So, you would have been calling it a donkey. Sometimes this word called pen has got associated with this thing. So, this is the type of thing. You see item, their representations, their relations and attribute. The rose is a flower. It smells good. This is attribute. This is rose. Representation is with the petals, with colors, okay. And then there are hidden things which are emotional. So, this is from a simple item, its attributes, the representation, everything really boils down to this huge symbolic representation in the brain. Okay. So, the summary is how nerve cells combine to perform complex cognitive functions. They form the basic building block, but some working assumptions we know, but we still have to answer a lot, and we will see and explore it in next few lectures. So, there will be more questions and there will be less answers. So, I will leave the questions to you, so you can carry on the next 50, 100 years of research, and but I hope you got an idea of how networks form. And so, thank you. I will see you in the next lecture.